Hi everyone. I apologize for not being there today. My daughter is sick, so we're going to do things a little bit differently. I will still give you the notes, so lucky you guys. All right, first thing I want you to do is go to our Schoology site and download the day 17 homework. Okay, so stop the video right now and go do that. Okay, so hopefully we were able to get that note sheet. Day 17, we're going to be talking about operations with matrices today. So we're going to be able to look at dimensions of a matrix, determine how to add, subtract, and multiply matrices, and we'll go from there. Okay, so today I was going to show you how to do this on your calculator, but that's really not important for tonight's homework because we'll have to do everything by hand anyways. So let's get down to it. Okay, so what exactly is a matrix? A matrix is a rectangular array of numbers. Sometimes we refer to these numbers as elements. Okay, so let's take a look at these four matrices down below. All right, one thing we should notice is going across, those are known as the rows. And these guys vertically, those are the columns. Okay, does anybody know how we state the dimensions of a matrix? Okay, you probably have heard of it. We discussed the dimensions of a matrix as the rows by columns. So let's quickly go up above and state the dimensions of these four matrices. In this first matrix here, you should recognize we've got two rows, so it's 2 by, and we have 3 vertical columns, so a 2 by 3 matrix. This second matrix, we have 1, 2, 3 rows, and 1, 2 columns, so it's a 3 by 2 matrix. This third matrix is a 1 row, 1 by 1, 2, 3 columns. And finally, this last matrix here has 2 rows and 1 column, so it's a 2 by 1. Okay? Being able to identify the dimensions of a matrix is very important from here on out. Okay? So let's get down to adding and subtracting matrices. Okay, so like I said, we're going to kind of skip the calculator portion today. We're going to go right to adding and subtracting matrices by hand. Okay, so let's go to the conclusion first. I'll start with the important piece. In order to add and subtract matrices, the matrices must have the exact same dimensions. Okay, so we can do this when the matrices have the same dimensions. If they don't have the same dimensions, we can't add them. Okay, so let's go back up to these 3 matrices, A, B, and C, and let's just start with their dimensions. Okay, so let's look at matrix A. Hopefully you recognize the dimensions are 2 by 3. Matrix B, also 2 by 3. And matrix C are 3 by 2. Okay? All right, so how do we add matrices by hand? Well, let's look at this first example here where we're taking matrix A and adding it to matrix B. First, do they have the same dimensions? So we have a 2 by 3 and a 2 by 3. So since they have the same dimensions, we can go ahead and add these together. So let's do that. So matrix A is 5, 2, 7, 1, 3, 9, and we are adding that to 4, 6, 8, 5, 1, 3. Okay, so when we're adding, we're going to add the elements that are in the same exact location. So this element here in matrix A, 5, is in the same position as 4 is. So we add those together. So that row 1, column 1 gets added to that value that's in row 1, column 1 of the second matrix. So we're going to get 5 plus 4, we get 9. Okay, then I'm going to add 2 and 6 together, and we get 8. Then we'll add 7 and 8 together, and we get 15. And then we go down. 1 plus 5 is going to give us 6. 3 plus 1 is going to give us 4. And then finally 9 plus 3 is 12. So the sum of these two matrices is that matrix there, 9, 8, 15, 6, 4, and 12. And if we recognize, our dimensions stay the same, a 2 by 3 matrix. Okay? So the same rule applies with subtraction. So we subtract the elements that are in the same exact position. So in this example here, when we have B minus A, order is important, 4, 6, 8, 5, 1, 3, minus matrix A, 5, 2, 7, 1, 3, 9. And now we go ahead and we subtract the elements that are in the same exact location. So we have 4 minus 5, so that's negative 1. We have 6 minus 2, so that's 4. We have 8 minus 7, so that's 1. We have 5 minus 1, so we get a 4. We have a 1 minus 3, so there's a negative 2. And then finally a 3 minus 9, so that's going to be a negative 6. So the difference of these two matrices is that there, okay? So if we take a look at number 3, and we compare the dimensions, well, remember, matrix B is a 2 by 3, and matrix C is a 3 by 2. These are not the same dimensions. So we cannot find the sum. There's a dimension mismatch. So no sum can be found. Okay? So hopefully you guys picked up on that. Let's move on to multiplying matrices. Okay, before we get into actually multiplying matrices, we are going to talk about multiplying by a scalar. Multiplying by a scalar is just like multiplying by a coefficient of any quantity. All we're going to do is distribute that 5 to every element inside, and our elements stay in the same position. So it's going to look like the following. 5 times 2 gives us 10. 5 times 4 is 20. We have another 5 times 4, so that's going to go in row 1, column 3 of 20. 5 times 6, we get 30. 5 times negative 1 is negative 5. 5 times 0 is 0. Okay, and that's it. We're done. We can move on. Okay? All right. Multiplying. Okay? Multiplying is a little trickier than adding and subtracting. Okay? So before we go on to actually multiplying by hand, let's state our dimensions. Okay? So I believe these are the same matrices as the front. Oh, no, they're not. They're a little different. Okay, well, that's fine. Matrix A, we have a 2 by 3. Matrix B, also a 2 by 3. And matrix C is a 3 by 2. Okay? So, if we wanted to multiply A times B, we would not be able to. Go figure. Okay, we have a 2 by 3 and a 2 by 3. we can't multiply these together. So just because matrices have the same dimensions doesn't mean you can multiply them, okay? There's a special rule. So here we have a dimension mismatch, and I'll tell you why in just a second. Let's go down to the bottom of the page, okay, before we actually get into multiplying by hand. All right, so here's a rule. When we multiply matrices, okay, we can't just multiply them if they have the same dimensions. Something needs to match up. So what we do is we compare the columns of the first matrix to the rows of the second matrix. If those match up, we're good to go. So when can you multiply matrices? When the columns of the first matrix match the rows of the second matrix. Okay? So let's take a look up here. So when we're multiplying, okay, I look at the columns of the second matrix, the columns of the first matrix, and in this case it's a 3, and I compare that to the rows of the second matrix. Those don't match. Therefore, we cannot multiply them. Okay? So let's take a look at number 2, A times C. We always start by stating the dimensions. So we have a 2 by 3 and a 3 by 2. All right, I compare the columns of the first matrix to the rows of the second matrix. Since those match, we can go ahead and multiply. So let's see how we do this. Okay, so let's rewrite our two matrices. So we want matrix A, 5, 2, 7, 1, 3, 9, and matrix C, 6, 5, 2, 3, 4, 7. Okay, so the way we do this is we're going to multiply the rows in our first column, or in our first matrix. So I like to circle them, okay, by the columns in the second matrix. So the columns in this one are a group, okay? And what we're going to do is we multiply the first element in each group by the first element, okay? And then we add that to the product of the corresponding elements. So what does this look like? Okay, it's going to be this 5, okay, times 6. Those are both the first elements in each group, okay? Then I add that to 2 times 2. Those are both the second elements in each group. And then I add that to 7 times 4, the last elements in each group. So that was row 1 times column 1. This value goes in row 1, column 1 of our product matrix. Okay? So now we have to do it again. Now this time I multiply row 1 times column 2, and that's going to go in position row 1, column 2 of our product matrix. So this time it's 5 times 5, the first elements get multiplied, plus the second elements, 2 times 3, okay, plus the last elements multiplied, 7 times 7. Okay, so that is row 1 times column 2. Now we have to do this all again for row 2. Okay, so now I'm going to multiply row 2 by column 1. So we have 1 times 6 plus the second element 3 times the second element 2 plus the third element 9 times the third element 4. So that was row 2, column 1. It goes in row 2, column 1 of our product matrix. Okay? All right, now we have to do the same thing for row 2, column 2. Okay, so 1 times 5, those are the first elements, plus the product of the second elements, 3 times 3, and plus the product of the third elements, 9 times 7. And now we just clean these up. So row 1, column 1, 5 times 6 plus 2 times 2 plus 7 times 4, I believe we get 62. Okay? Row 1, column 2, 5 times 5 plus 2 times 3 plus 7 times 7, and that's going to give us 80. Okay? And then row 2, column 1, 1 times 6 plus 3 times 2 plus 9 times 4 gives us 48. And then finally, row 2, column 2, 1 times 5 plus 3 times 3 plus 9 times 7, we get 77. Okay, so the product of A times C is 62, 80, 48, and 77. Note the dimensions, a 2 by 2. Okay, well, let's take a look back at the original dimensions of matrix A and C. Notice the outside values. Okay, the row of the first matrix and the column of the second matrix are going to give us the dimensions of our product matrix, which we got a 2 by 2 matrix. So let's go down to the bottom and fill that last portion out. So how do you determine the dimensions of the product matrix? It's simply the rows of the first matrix by the columns of the second matrix. Okay? All right, so now what I want you guys to do on your own or with a classmate is find the product of matrix B times C. So this example 3 here, your answer should be the following after you clean it up: 68, 94, 44, and 49. Okay, so your homework tonight is to not use a calculator. It is day 17, no calculator. Okay, I'll see you tomorrow, so bring any questions that you have.